So we shall now continue with the uses of the penicillin. What are the therapeutic uses of penicillin? Mainly, we mean the narrow spectrum penicillin. So previously, narrow spectrum penicillin was the drug of choice for most of the infection, but with the advent of the newer antibiotics, its use is now restricted. But for still few some infection, is common drug of choice is penicillin, like Corynebacterium diphtheria, like Treponema pallidum, and other viral infection, like Listeria, like actinomyces, and Clostridium perfringens infection. The drug of choice is still penicillin, or even some streptococcal infection also. So remember this Corynebacterium, Treponema, other Pyruvita, Listeria, actinomyces, and Clostridium perfringens infection. We use penicillin, and penicillin G is the effective dose range between 4 to 24 million units per day, administered IV every 4 to 6 divided doses. So remember the dosage frequency is very frequently given because penicillin acts on the principle of T by MIC. That means more the time it remains above is constant remains of the MIC, then better is the killing. Unlike the aminoglycoside of fluoroquinolone, which exert their action by Cmax by MIC, that means more the maximum concentration above the MIC, more will be the killing. So as penicillin acts on this T by MIC action effect, then that means we have to give the drug more frequently so that its concentration remains above the MIC for the most of the time. Narrow spectrum penicillin is penicillin V, that is given orally, both the poor bioavailability and narrow antibacterial spectrum. Another is narrow spectrum penicillin are also benzathine penicillin G and procaine penicillin G, and benzathine penicillin and benzathine penicillin is used in treatment of the primary and secondary syphilis as well as treatment of the prophylaxis of the rheumatic fever. So intramuscular injection of benzathine penicillin 2.4 million units is effective in prophylaxis of rheumatic fever. IM every 3 to 4 weeks up to 21 years or for 5 years, whichever is longer. That means if patient suffers from rheumatic fever in 10 years, then for next 11 years, that means until she attains with 21 years, it need to be repeated every 3 weeks. But if she is attacked with rheumatic fever in 19 years of age, then she need to be given up to 24 years for 5 years. And benzathine penicillin also is used in treatment of the primary and secondary syphilis. Primary syphilis dose is single dose, secondary syphilis every 3 weeks, weekly dose, intravascular. For tertiary syphilis, which is commonly associated with CNS involvement, then we use procaine penicillin, because benzathine penicillin is a very long acting, is a large molecule, it cannot penetrate the CNS. So procaine penicillin is used in treatment of the tertiary or neurosyphilis. Next, penicillin is resistant penicillin or anti-staphylococcal penicillin. So previously, when they were discovered, it was thought that anti-pseudomonas penicillin, anti-staphylococcal penicillin will be active against the Staphylococcus aureus, because Staphylococcus became resistant by expression of the penicillin S. So axoxyllin, cloxoxyllin, and dicloxoxyllin, flucoxoxyllin, they were produced. They can have anti-penicillinase action. That means they can prevent degradation by penicillin S. But later, Staphylococcus aureus found to be resistant against those organisms, those drugs also, because Staphylococcus aureus derived another method of resistance, that is altered penicillin binding protein, and that's why the drugs oxoxyllin, oxoxyllin, dicloxoxyllin, also methicillin. Methicillin was also an anti-staphylococcal drug. They were penicillin is resistant, but they are not active against the altered penicillin binding protein containing staphylococci. That's why Staphylococcus penicillin binding protein cannot recognize this drug. That's why they remain ineffective. And these are called methicillin resistant Staphylococcus aureus. So Listeria and penicillin resistant strains of Staphylococcus aureus are resistant to these drugs also. And these are chemosynthetic drugs, and penicillin susceptible strains of streptococci, pneumococci are also susceptible. And these are relatively acceptable and have reasonable viability. Extended spectrum penicillin. So until this group of penicillin, they are narrow spectrum or penicillin resistant penicillin. They cannot penetrate the gram-negative bacteria. They cannot penetrate the outer membrane of the gram-negative bacteria. But extended spectrum penicillin, they can penetrate the outer membrane of the gram-negative bacteria. Examples are ampicillin, amoxicillin, and piperacillin, carbapenicillin. So basic question is that beta-lactamase inhibitor is combined commonly with the extended spectrum penicillin, not with the anti-staphylococcal penicillin. Why? Because anti-staphylococcal penicillin cannot penetrate the outer membrane, so cannot reach the peptidoglycan layer, which is and unless they reach peptidoglycan layer, then only there is chance of damage of the drug by the beta-lactamase enzyme. So as they cannot penetrate, beta-lactamase inhibitor cannot enhance their action against the gram-negative. Whereas extended spectrum penicillin, they can penetrate the gram-negative outer membrane, they can reach the peptidoglycan layer, and their action can be lost if there is beta-lactamase enzyme is there by the gram-negative as well as staphylococcus. And to prevent their degradation by beta-lactamase enzyme, beta-lactamase inhibitor is combined with the drugs like extended spectrum penicillin, ampicillin, amoxicillin, piperacillin, so that their action against the gram-negative remains present. So to be active against the gram-negative bacteria, penicillin must penetrate the outer membrane, as well as beta-lactamase inhibitor is then added only, so that it is not made inactive in the periplasmic area. And ampicillin, these drugs have greater activity than penicillin G against gram-negative bacteria because of their enhanced ability to penetrate. And as they are more prone to degradation by beta-lactamase, beta-lactamase inhibitor are commonly combined with them. So penicillin, ampicillin, amoxicillin, we have to read in detail. So ampicillin and amoxicillin both are aminopenicillin, and there are some similarities, some differences. Both are effective orally, and amoxicillin is better absorbed orally. Amoxicillin absorption is not interfered with food, and whereas ampicillin better to be given in empty stomach either 1 hour before or 2 hours after meal. Amoxicillin is dosing less frequently, 250 to 500 milligrams 3 times daily, whereas ampicillin same dose but given 4 times daily. So half-life is more with amoxicillin, and given orally, both can be given orally to treat urinary infection, sinusitis, otitis, and ampicillin among them can cause more antibiotic-resistant diarrhea, and it can rarely cause, it can sometimes cause pseudomembranous colitis due to Clostridium difficile. That is one kind of super infection. And ampicillin and amoxicillin are active against the beta-lactam antibiotics, are most active of the beta-lactam antibiotics against penicillin resistant pneumococci. And ampicillin, but not amoxicillin, is effective in the treatment of shigellosis. So ampicillin has two advantages. One is it is effective against shigellosis as well as effective against the manorops and listeria. Whereas amoxicillin has the advantage, it is duration action is little bit longer, so need to be given less frequently. Absorption is not interfered by food, and there is less chance of diarrhea with amoxicillin. Whereas ampicillin is not active against Klebsiella, Enterobacter, and Pseudomonas, Citrobacter, because ampicillin and amoxicillin, neither of them can penetrate to this peptidoglycan layer of these organisms, Klebsiella, Pseudomonas, Enterobacter, etc. Carboxypenicillin, example is carbenicillin and ticarcillin, not commonly used. You need not read much. It is the anti-pseudomonas carboxypenicillin, and it has exhibited anti-pseudomonas action, but later found to be resistant. That's why it is not active, and also it is less active against ampicillin, less active than ampicillin against enterobacter. Next, you have to know something about the piperacillin. That is a group of ureopenicillin. It is active against selected gram-negative bacilli such as Klebsiella pneumoniae. It has anti-pseudomonal action. So far, anti-pseudomonal action is not present with any of the penicillin. We have discussed narrow-spectrum penicillin. We have discussed anti-staphylococcal penicillin. But among the extended spectrum penicillin, piperacillin is having anti-pseudomonal effect, and this is frequently used in combination with an aminoglycosides. So Pseudomonas is once again a notorious organism just like Staphylococcus, and most of the drugs cannot penetrate it, most of the beta-lactam drugs, but piperacillin can penetrate it. But as penicillin and beta-lactam and penicillin and aminoglycoside act synergistically, so for better action against Pseudomonas, only piperacillin is not used often. It need to be combined with the aminoglycoside. And then another basic question: what is extended spectrum penicillin and what is broad spectrum penicillin? There is no term called broad spectrum penicillin, because extended spectrum penicillin exerts their action against gram positive and gram negative, whereas broad spectrum antibiotic means these are active not only against the bacteria but also some parasites, like tetracycline is active against entamoeba, tetracycline is active against malaria species, some malaria species. That's why they are called broad spectrum antibiotic. So for broad-spectrum antibiotic, they need to be not on their activity is present outside the bacteria world also. So they are called broad-spectrum antibiotic. But here penicillin's activity, external penicillin, generally activity on the gram-positive and gram-negative. And beta-lactamase inhibitors are commonly combined with these external penicillin because they are potent inhibitor of the majority of the beta-lactamase. So beta-lactamase enzyme produced by the gram-negative, they can damage the drugs which have entered into the gram-negative cell wall, and that's why beta-lactamase inhibitor, if they are combined with the ampicillin, amoxicillin, piperacillin, their activity against gram-negative bacteria is still present. And ampicillin is combined with sulbactam, amoxicillin is combined with clavulanic acid, piperacillin is combined with tazobactam. So these are the sulbactam, clavulanic acid, tazobactam. They are beta-lactamase inhibitor. They are also one group of beta-lactam drugs, but their own activity is absent. They do not have their own antibacterial activity, so they need to be combined with other beta-lactam drugs like ampicillin, amoxicillin, piperacillin. So remember, ampicillin is combined with sulbactam, piperacillin is combined with tazobactam, amoxicillin combined with the clavulanic acid. Not in other ways. So ampicillin cannot be combined with clavulanic acid, piperacillin cannot be combined with the sulbactam, amoxicillin cannot be combined with tazobactam like that because of their pharmacokinetic matching. Amoxicillin pharmacokinetics matches with the clavulanic acid, ampicillin pharmacokinetics matches with the sulbactam, that's why they are combined. So these are the beta-lactamase inhibitors obtained from the Streptomyces clavigeres. It has a beta-lactam ring but no antibacterial activity on its own. Inhibits a wide variety of the beta-lactamase produced by the both gram-positive gram-negative bacteria. It is a progressive inhibitor. It binding with the beta-lactamase is reversible but becomes covalent later. Also it is called a suicide inhibitor. It gets inactivated after binding to the enzyme. So clavulanic acid, Streptomyces clavigeres is the source. Cephalosporin source is Cephalosporium. That is another fungi like the penicillium. And clavulanic acid also obtained from a bacteria that is called Streptomyces clavigeres. That's why they are all antibiotics and having beta-lactam ring, but they are not active alone. They need to be combined with the amoxicillin for their action. Viability 60%, can also be injected. Its limited half-life is 1 hour. Tissue distribution matches amoxicillin, and it is eliminated mainly by the glomerular filtration. Its excretion is not affected by the probenecid. So probenecid inhibits the excretion of the amoxicillin but not clavulanic acid. And what is the advantage? Addition of clavulanic acid reestablishes the activity of the amoxicillin against the beta-lactamase producing taste and staph aureus, but not against MRSA that have altered PEPs. H. influenzae, gonorrhea, Neisseria gonorrhea, E. coli, Proteus, Klebsiella, Salmonella, Shigella. So the organism which are producing beta-lactamase enzyme, beta-lactamase inhibitor, if combined with the amoxicillin, then their activity is not lost. Okay, so the amoxicillin remains active against these gram-negative only if they are combined with the beta-lactamase inhibitor, clavulanic acid. Otherwise, their activity will not be present because these drugs will be destroyed by the beta-lactamase. Similarly, sulbactam, that is also progressive inhibitor, is highly active against class 2 to class 5 beta-lactamase, preferably given parenterally. It has been combined with ampicillin for use against beta-lactamase, producing resistant strains. And so ampicillin and sulbactam IV given for most of the infections, including Listeria, Shigella, and there is an oral drug. Absorption with complex salt with ampicillin, saltamicin, tosylate is better. So saltamicin, tosylate plus ampicillin can be combined, which is given orally. Indications: PPNG gonorrhea, that means penicillin is producing Neisseria gonorrhea. Amoxiclav, this is the name of amoxicillin clavulanic acid. Indications are soft and tissue infections, infection, intra-abdominal gynecological sepsis, urinary biliary tract infection, respiratory infection. Also, it was a drug commonly used for gonorrhea, including the penicillin producing Neisseria gonorrhea. Single dose is sufficient, single dose 3 gram, and often it is combined with probenecid plus clavulanic acid. So remember, so which drugs action is in which drugs can increase the action of the amoxicillin? Of course, we can use aminoglycoside, we can use probenecid, we can use clavulanic acid. Their mechanism of action are different, but all help to increase their duration of action or increase their activity against the organisms. So ampicillin sulbactam, indications of PPNG gonorrhea. Sulbactam itself has some Neisseria gonorrhea-like anti-gonorrhea action, and also it can be used in skin soft tissue injury, infection, gynecological sepsis, and hospital-acquired infection. Tazobactam, that pharmacokinetic matches with the piperacillin, and it has been combined with it for severe infections like peritonitis, pelvic, urinary, respiratory infection caused by beta-lactam producing bacilli. And this combination is not active against piperacillin-resistant Pseudomonas. So, Pseudomonas infection is very difficult to treat, and piperacillin has some activity against it, and piperacillin-tazobactam combination is better. But some Pseudomonas also have altered coding channels that piperacillin cannot penetrate into them, and that's why addition of the piperacillin-tazobactam even cannot regain the action of the piperacillin. So, the combination is not active against the piperacillin-resistant Pseudomonas. So, if culture report shows that Pseudomonas is resistant to the piperacillin, don't expect that piperacillin-tazobactam combination will be helpful. Then we have to use other group of drugs. But otherwise, piperacillin, if it shows sensitivity, piperacillin-tazobactam will work better in Pseudomonas infection, and often it is combined with some aminoglycoside to have synergistic effect. Next, cephalosporins. So cephalosporins are similar to penicillin. Cephalosporium is the source, or the new name of that fungi is called Acremonium. Mechanism of action is same. That means it inhibits the transpeptidase enzyme and prevents the cross-link formation between two layers of peptidoglycans. And it is more stable against beta-lactamase, substituted 7-aminochlorofuronic acid, and they are relatively more acid stable. Now, cephalosporins, there are many drugs of cephalosporins. First generation to fifth generation, they have been classified. And what is the basis of this classification? So, commonly we know that beta-lactam drugs are generally more active against the gram-positive bacteria. For gram-negative action, they need some special characteristics. Similarly, first generation cephalosporins are active against the gram-positive bacteria. They have negligible activity against the gram-negative, and as the generation progresses, there is more increase in the gram-negative activity and decrease in the gram-positive activity. That means second generation cephalosporin, there is increase in the gram-positive, increase in the gram-negative activity, decrease in the gram-positive activity to some extent. Third generation cephalosporin, they have balanced gram-positive, gram-negative action. Fourth generation cephalosporin, predominantly gram-negative action, some gram-positive action. Fifth generation cephalosporin, predominantly gram-negative action, but have some good gram-positive action also. So remember few examples of each. Cefadroxil, among them there is some of them are given orally, some of them given IV. It is difficult to remember, but you need to read it again and again to remember their name. So I am mentioning the commonly used cephalosporin, which you need to remember. Among the first generation, remember the cefadroxil and cephalexin, which are given orally. Cefazolin, which I have read in the surgical prophylaxis, it is given IV, cefazolin. Second generation oral drug is cefaclor, cefuroxime, and cefoxitin, cefotitan are parenteral. Third generation cephalosporin, ceftriaxone, ceftazidime, and cefoperazone, they are parenteral. Cefixime and cefodoxime are oral. Fourth and fifth generation cephalosporin, all are given parenterally. Cefepime, cefepime, and fifth generation there is ceftaroline, ceftibaprol. And cephalosporins, first generation cephalosporins, these are cefadroxil, cefazolin, cephalexin. They are active mainly against the gram-positive bacteria. You need not read it much. And remember, the second generation and there is cefazolin which you use in the treatment of the surgical prophylaxis. And it can be, cefazolin can also be used in some infections in some penicillin allergic patients. Second generation cephalosporin, they are active against gram-negative, including some Klebsiella, H. influenzae, and remember some of them have anti-anaerobic action like cefoxitin, cefometazole, and cefotitan are active against anaerobes like Bacteroides fragilis and some Serratia strains, but they are not active against Pseudomonas or Enterobacter. And second generation cephalosporin, the IM injection is painful, should be avoided, and either they are given orally or by IV route. And clinical use, primarily used to treat sinusitis, otitis, or lower respiratory infection. Cefuroxime is used in community acquired pneumonia. Cefotitan and cefoxitin, they are used in some anaerobic infections like peritonitis, diverticulitis, etc. And third generation cephalosporin. So as they have balanced gram-positive, gram-negative action, they are often used as empiric therapy in sepsis patient, when cause of the organism is not, cause of the infection or the organism is not known. So to cover all the gram-positive, gram-negative, often third generation cephalosporin are chosen as the empiric therapy, and often it is combined as compared to the second generation drugs. They have expanded gram-negative coverage, and among them some have anti-pseudomonal action. So far, first generation and second generation cephalosporin are not active against pseudomonas, but cefoperazone and ceftazidime among the third generation cephalosporin have some anti-pseudomonal action, and ceftriaxone and moxalactam have some action against the anaerobes like Bacterioceralis. So remember these two special groups. One has some anti-pseudomonal action like ceftazidime and cefoperazone, whereas ceftriaxone and moxalactam active against the Bacterioceralis. Third generation cephalosporins, they penetrate the body fluids and tissue and achieve levels in cerebral venous fluid sufficiently, except pseudomonas meningitis, and excretion of the remember all of these cephalosporin are excreted by the renal route, but exception is cefoperazone and ceftriaxone. They are presumably biliary excreted. That's why cefoperazone, ceftriaxone need not require dose adjustment in the renal failure patient. Third generation cephalosporin, there is a wide variety of serious infection caused by organisms that are resistant to most other drugs, and strains expressing extensive spectrum beta-lactamase, however, not susceptible. So ceftriaxone, cefotaxime approved for the treatment of meningitis caused by the pneumococci, meningococci, H. influenzae, except Listeria. So except Listeria is mainly related by the ampicillin. And ceftriaxone, cefotaxime are the most active cephalosporin against the penicillin-resistant strains of the pneumococci. So ceftriaxone, cefotaxime, they are mostly used in treatment of the meningitis, and also it can be used in treatment of some pneumonia, and vancomycin is often added in the meningitis. Empirical therapy of sepsis of unknown case, as they have both balanced gram-positive, gram-negative activity, and it can be used in some neutropenic febrile immunocompromised patient. They are often used in combination with an aminoglycoside to have better action. So aminoglycoside, they are predominantly active against the gram-negative, and with cephalosporin they have synergistic activity, and ceftriaxone, as they have activity on gram-positive, gram-negative both. So that ceftriaxone aminoglycoside is a very good combination to be used. Next, fourth generation cephalosporin, cefepime and cefepirone. Before discussing this fourth generation, cefoperazone has another few unique property. So cefoperazone is an anti-pseudomonal penicillin, and also it is excreted biliary route. But cefoperazone has these problems also: disulfiram-like reaction and hypophosphatemia. It can cause bleeding disorder. So cefoperazone, it can cause disulfiram-like reaction. Disulfiram-like reaction means accumulation of the aldehyde, which is causing the discomfort in the patient, can cause palpitation, sweating, tremor, coma, hypotension, etc. And it is due to accumulation of the aldehyde because of aldehyde dehydrogenase inhibition by the cefoperazone. So cefoperazone inhibits the aldehyde dehydrogenase, so there is more accumulation of the aldehyde in the chronic alcoholic patient. That's why there is chance of disulfiram-like reaction. So before giving cefoperazone, history of alcohol intake must be present, and also it can cause bleeding disorder. Fourth generation cephalosporin, cefepime, cefepirone, they are more resistant to hydrolysis by the beta-lactamase, and also they have some good activity against the Pseudomonas aeruginosa and Staph aureus. Cefepime is highly active against Haemophilus and Neisseria. It penetrates well into cerebrospinal fluid, and good activity is present against the most penicillin-resistant strains of the Streptococci and also Enterobacter. So remember, they are active against the Pseudomonas aeruginosa, Enterobacteriaceae, and Staph aureus and Streptococcus, also active against the Haemophilus influenzae and Neisseria. And so mainly their action is seen on few gram-positive, but predominantly on the gram-negative. And fifth generation cephalosporin, ceftaroline and ceftabiprole, they are active against the gram-positive, gram-negative both. They have some anti-pseudomonal action, but predominantly they are unique because this is the only cephalosporin, that is the fifth generation cephalosporin, have the activity against MRSA, methicillin-resistant Staph aureus infection. So what are the adverse effects of penicillin, cephalosporin? Allergic reaction is same, and though some individuals with a history of penicillin allergy may tolerate cephalosporin, but rational approach is that patients with a history of anaphylaxis to penicillin should not receive cephalosporin, and it can produce some local toxicity, thrombophlebitis after intravenous injection, and cephalosporin containing the methyl thiotetrazole group. they have two unique these adverse effects. One is called hyperprothrombinemia and bleeding disorder like cefoperazone, cefotitan, and also they can cause disulfiram-like reaction. And also there was one drug, cephalosporin, now discontinued. It can cause interstitial nephritis and acute tubular necrosis. So these are the commonly used cephalosporin, which you need to remember, first to fifth generation, and their specific uses and their specific properties of the ceftriaxone and cefoperazone. Remember, ceftriaxone and cefoperazone, they need not be reduced, and their dose need not be reduced in the renal failure patient.